Today we're going to use similar figures to find unknown measures of different shapes. We are going to be looking at indirect measurement, which is a method of using proportions to find an unknown length or distance in similar figures. Okay, so the first thing we're going to do is we are going to write a proportion using corresponding sides. Proportion, they don't give me enough room. So what we want to do is we want to take a corresponding side from the big triangle and the little triangle. Now, I always say start with the little triangle. So we have the little triangle, that's what the L stands for, over the big triangle. Okay? I just do that because I just do. So they took GH from the little triangle and put it in the numerator, and then put that over the corresponding side of the big triangle, which was BC. Okay? Then they took JG from the little triangle and put it over the corresponding side of BA from the big triangle. Now we're going to substitute the lengths of the sides. So GH is X, so they put an X in there, over BC, which is 6, JG, which is 5, over BA, which was 10. Now, when you are solving for an unknown measure, one of your corresponding sides must contain the variable, because if it doesn't, then you can't find the unknown side. We're going to find the cross products. So we're going to take 10 times x equals 6 times 5. 10 times x is 10x, 6 times 5 is 30. And then we have a coefficient times a variable, so we're going to divide each side by the coefficient of 10. That cancels these 10s. We bring our x down, and 30 divided by 10 is 3. So this x is 3 centimeters. So if you don't use one of your corresponding sides of the unknown, you're not going to be able to find the answer. And the whole point of this is to find the unknown side. So that's not going to help you out. The inside triangle is similar in shape to the outside triangle. Find the length of the base of the inside triangle. So let's look at this. We're going to let x equal the length of the inside triangle. It already does. Okay, we already know the length is the base. Okay, so we're going to take corresponding sides, and because they already have the x there, this is the little triangle, the x, the first denominator also has to be a little triangle. You have to keep your little triangles in the same place, either in the numerators together or the denominators together, and your big triangles in the opposite. So if we have the x of the little triangle here, our little triangle needs to go here as well. Okay, now the corresponding side with x from the big triangle, since the x is this line, the corresponding side is here, and it is 12. Alright, and the corresponding side of the little 2 is the 8. So notice how we kept our big triangle lengths up top, our little triangle lengths in the bottom. We're going to find the cross products now. So we have 8 times x equals 2 times 12. 8 times x is 8x, 2 times 12 is 24. And for whatever reason, they decide that we should write that again. And then, because we have a coefficient with a variable that shows multiplication, the opposite of multiplication is to divide by the coefficient, which is 8. So we're going to divide both sides by 8. That cancels this. We bring the x straight down, and we get 24 divided by 8 is 3. So the length of the base of the inside triangle is 3 inches. And our last problem says, city officials want to know the height of a traffic light. Estimate the height of the traffic light. So we're going to look at this as two triangles, okay? The triangle with the stop sign, so this is the stop sign. Stop sign. It shows us that the height is 15. I got that right here. And that the length is 27.25. Okay, and I got that from right here. And now we need the big triangle. And this is the light. Alright, and it shows us that the height, we don't know. It's just an H. Got that there. But the length is 48.75. And I got that down at the bottom here. Okay, so we're going to do our sign over our light. So that means our sign lengths are going up top, our light lengths are going in the bottom. So we are going to start with 15, and the corresponding side of 15 is x, because it's both the heights, equals, and then we have to do our length because we know our lengths down here at the bottom, and we're going to do the sign first because our sign is going up top of 27.25 over the length or shadow or whatever you want to call it of the light, which is 48.75. So we wrote a proportion. Now we're going to use compatible numbers to estimate. We don't need to estimate yet, so we're just going to instead multiply cross products. So cross that out. Multiply cross products. So we have 27.5x equals 15 times 48.75. Oops, clear. 48.75. And we have 731.25. Then, because there's a coefficient, we're going to divide each side by 27.25. That crosses these out. We bring our x straight down, or our h, and we divide 731.25 divided by 27.25, and we get 26.83. So that is the height of the traffic light. Honestly, I would rather you just find the actual height than go through and round numbers and all that. Okay, so you can just do those problems just like we've been learning. You keep the sign triangle or the small triangle up on top, the big triangle or the light triangle on the bottom in this case. So go ahead and do your check it out to find your unknown measures.